Well, hello, good afternoon. Thank you for attending this LISTalk organized by the Luxembourg Institute of Science and Technology. Today, we have a webinar talking about smart local energy systems, okay, the key for unlocking grid flexibility. This seminar is part of a series of webinars that we had been giving in the last months and that will result in an event that will be held in Luxembourg by the end of May. Okay, the energy transition dialogues, the energy transition dialogues in Luxembourg that will be held on 30th of June. And today, as I mentioned, we are going to deal with a webinar that will address the growing importance of local energy systems in order to support the transition to a fully decarbonized society. On the one hand, striving on decarbonization will require a more flexible use of distributed energy sources, particularly renewable-based energy resources, taking full advantage of their presence in distribution grids. On the other hand, citizens' engagement is required as consumer. Now they will be turned into prosumers, and they will have an increasing active participation in energy supply and demand, okay, in the future energy systems. In this context, concepts around smart local systems such as macro-grids or renewable energy communities can be an effective means to unlock this flexibility and enabling the management and coordination of generation, storage, and demand assets, and facilitating the integration of several stakeholders involved in the energy system. So today we are going we have two guests to present two perspectives on this topic. Just to inform you a little bit about the agenda. And now after this introduction, our first speaker from the industry will give a presentation maybe for 15 minutes. During this time, you can put your questions, okay, about the presentation. Later, we will spend maybe 5-10 minutes talking about attending your questions. And after that, our second speaker, which is present the LIST perspective on this local energy system topic. And at the end, 10 minutes before 4, we will open up a round of questions in order to make a global discussions of what presented today. Okay. So, well, without delaying more this introduction, of extending more this introduction, let me introduce to our first speaker. Our first speaker is Lucia Rakosevic. She is the RD manager Lucia is a RD manager at the Think-E, a Belgium-based engineering and consulting company that helps prepare enabling framework and implementing technologies needed for energy transition across Europe. She is currently leading or involved in the implementation of European projects such as DECIDE, the Clean Energy for European Islands Secretariat, the Smart Cities Marketplace, the Covenant of Companies for Climate and Energy, etc. Within these projects, she has direct contact with the community energy initiatives on the ground and understanding on how different energy actors interact or can interact to help accelerate energy transition. Lucia has more than 10 years experience in sustainable energy field from research and innovation, private and public sector perspective. Lucia has degrees in physics and computer engineering from University of Arkansas, United States, master in mechanical science and engineering from University of Illinois, Urbana-Champaign, in United States, and a PhD in electrical engineering from University of Leuven in Belgium. Okay, so Lucia, thank you very much to be with us today here, and well, you have a floor. Thank you.
Thank you, Pedro. Welcome everybody. Thank you for joining us today. I will share with you. I'll try to be relatively short so that we have time for questions. I wonder if you see my presentation. I'll put it in presentation mode. Can you see that?
Yes, perfect. We see the presentation.
Okay. Just a second. For some reason, I don't see the presentation. All of a sudden. Here we go. Okay, so what I wanted to talk to you about today, we hear a lot about energy communities, let's say helping grid flexibility or solving a lot of different issues that are there in regards to energy transition. And I want to address this specific topic of what can energy communities do for grid flexibility and maybe what they can't do, what we maybe expect a bit too much. So to walk into that topic, I want to discuss what are energy communities. We have published within Smart Cities Information System this publication, Energy Communities, that you can check out, which is a bit more about urban context, but it goes into explaining what is considered energy communities under the European directives. So today we have two European directives, Renewable Energy Directive defining renewable energy communities and Electricity Market Directive defining citizen energy communities. And while both of these communities are defined within energy directives, they are as much of a social concept as they are an energy concept. And what does that mean is that even though, for example, renewable energy communities is more local and it's more concentrated on renewable energy only in different vectors of energy, so electricity, heating, and transport, whereas citizen energy communities is more, it doesn't have to be local and it's concerning electricity only. However, both of these have this, let's say, same view that their main reason for existence needs to be social, then environmental, and then lastly economic. And economic in a sense that whatever the benefit is, financial benefit of energy communities should be returning full cycle back to the community and sort of helping other community initiatives in regards to environment and social cohesion. And so from that bigger picture of what energy communities are, what are some of the main benefits that are seen of energy communities within energy transition? One is just an inclusive energy transition, so including those stakeholders, even local stakeholders or regional, that are not typically included in energy sector. So aside from energy companies or let's say those front runners that we usually see in the energy transition, including also other parts of the society. Then the goal of energy communities is also to push, let's say, more citizens to become more proactive, as we heard also from Pedro, going from consumer to prosumer and having citizens that are more aware of their energy use, of their potential energy savings, of what renewable energy can do for them and for their community. And then finally, it's also to mobilize private capital to help accelerate energy transition, because it's easier to talk to the community than to talk to one person per one person and then push energy transition this way. So this is sort of a bigger picture of what energy communities are foreseen to do. But then looking from the grid flexibility, can energy communities help or increase grid flexibility? And there isn't really a yes or no answer, even though a lot of times we hear this as, let's say, binary. People say, yes, definitely energy communities is one of the benefits. It depends. It depends on two main things. One is, we say, business model of energy activity within energy communities, or basically what are the main energy activities around which energy communities is formed. We have a Horizon 2020 project called Decide, where and this is one of the publications within Decide, where we look into the different types of business models that energy communities, but also collective actions, and I'll come back to that in a minute, can do. So what types of business models they use to create benefit that can go back to the community. And why is this important for grid flexibility? Because, for example, if this business model includes managing a grid or having a microgrid, or using, let's say, aggregation services, then it's more directly related to helping or affecting grid flexibility. Whereas in some cases where energy communities exist and they do different aspects of energy activities, they might not have any influence on grid flexibility. Then when we go to the second aspect is sort of the location or the characteristics of where an energy community is. That being said, in some cases, there isn't much of the grid constraints at this point, and you can still add a lot of renewables, you can still add a lot of flexible assets without having any constraints from the point of view of grid flexibility or understanding that you need more flexibility in the grid. Whereas, for example, in the case which Pedro mentioned, we work with European islands. For example, in the case of a small island where you have limited capacity, you also have a grid that needs updating. All the stakeholders on the island need to work together, and the easiest to do this is through energy communities to help them manage their energy together, maybe have an assets that they own together, which can better help flexibility of the grid than if they own each one of them consider their own self-consumption only. So these are the two main aspects where we say, okay, can energy communities affect grid flexibility? Yes and a no, and it depends on these two. So it depends because there is what we see a lot of different types of energy communities, or what I mentioned earlier, collective actions. And what do we mean by collective actions? It's sort of a bit wider than what energy community is, and we're still trying to sort of define what that is, because currently it's not in regulation defined in most of the countries, and that's sort of activities that are done with the collective, with maybe not a specific community in mind, where they do energy activities that can eventually in different ways benefit a collective or a community that they work with. But one thing that we have to keep in mind, and why I keep coming back to this, that energy communities can, but maybe in certain cases are not very much affecting grid flexibility, is that you can also have improved flexibility of the grid without an energy community. So you don't have to have an energy community to have aggregation, for example. You don't have to have an energy community to have collective self-consumption or peer-to-peer exchange. In a lot of cases, that depends how the countries also implement the regulation, but you can do it through what we call collective action. So an aggregator or let's say an energy company that's doing aggregation for users that have heat pumps or electric boilers or electric vehicles can help in a way grid flexibility, but these users don't have to necessarily be part of an energy community. Then we try to call this a collective action. But then what if we look at this and we say, okay, then why are we talking about energy communities and how are they helping grid flexibility? From our point of view, there is sort of two aspects in which energy communities can really help. One aspect is that you mobilize higher participation of consumers or prosumers. What does that mean? Is that we know that in energy transition, there is going to be front runners. There's going to be people that are either involved in energy sector already that know about energy sector, or people that are more excited about new technologies, they want to learn about energy, they want to do they want to have a certain time in their life that they spend on analyzing what are different options that are there and how energy sector works. But there is also a big part of citizens of civil society that doesn't want to necessarily deal with this. They don't have time for this, or they have other priorities, and this is not something that they can do, and they wouldn't otherwise be pushed into energy transition or involvement into, let's say, flexibility services or offering flexibility or not, unless they're part of energy community, unless they're part of some community that they already trust that helps them manage energy. And then they say, okay, I'm part of energy community. Maybe I started with installing solar on my roof, but now I trust this community. We manage our energy together. And we also want to do some flexibility services, or we want to have somebody third party maybe manage our electric vehicle charging or are heat pumps, and this way those people that wouldn't necessarily be involved in the energy transition and help the flexibility of the grid can do that through energy communities. And then the second one is encouraging community energy management instead of self-consumption per user. What does this mean? For example, if we have a grid that has limited capacity and each of the neighbors on that line, for example, decides to manage their own energy so that they consume and they produce as much as they need. They're sort of closed system. They don't necessarily connect to the grid. That's nice from the point of view of the, let's say, their own flexibility and that they're not a burden to the grid per se, but they're not necessarily helping flexibility of that line because you still have a limited capacity of how much renewables you can add to the line. However, if you have consumers on one of the lines or users on one of the line working together through energy community, and they decide, for example, to install, let's say, a neighborhood battery, which is a together owned device or storage device, and then they manage it together. Then with that neighborhood battery, they can increase the capacity of that line to add more renewables or to add more flexible assets such as electric vehicles or heat pumps, and that way they're helping the flexibility of that line. So in that sense, energy communities, through that trust that they offer and let's say a possibility for managing energy within the energy community, they help also the flexibility of the grid. And one aspect that I want to mention before I finish the presentation, and that's that I always like to sort of mention energy communities as sort of in comparing to some other, let's say, a sports activity. For example, I don't know, badminton community, or it's not necessarily that energy community is very specific to energy and does this professionally. It's somehow a way within which you have a social aspect of a community, you build trust within a community, you create social cohesion, you're managing energy activities, but then the benefits of those activities come back to the community and are used maybe for some other activities. This is what energy community is meant as. So it's not just a vehicle for a specific energy action. It's much more than that, seen within energy transition. This is something that we have to keep in mind. Just like a badminton community is not just there to do professional sports or whatever, they're there also for the creating of the community and maybe doing additional activities together. So it's really important to keep this in mind when we talk about energy communities and what they can do for the energy system, that they're not there just for the energy system. They're there also for the social cohesion, for the, let's say, involving of the citizens in the energy transition, and for them to understand what are their effects on environment and on energy. That's everything that I wanted to cover, but I'm definitely here and open for any questions that you might have. Thank you so much.
So thank you very much, Lucia, for your nice presentation. Very, let's say, concise, precise. Let's say, going through the concepts actually regarding energy communities, and also just facing, or let's say, contrasting, okay, the interest for providing flexibility services to the grid, and also the let's say covering the differences between self-consumption and energy communities. Well, now we have some questions from the audience. Okay, well, maybe in these minutes, just before going to the next presentation that will be given by Andre, I have here a question which is regarding. It's a question asking, but do energy communities have to be local?
Well, energy communities don't necessarily have to be local, and within the directives, there is, as I mentioned, there's two types. So renewable energy communities are seen as local, whereas citizen energy communities are not. However, that also depends how the national regulators transpose the directives, because the directives are seen as sort of let's say, a generic framework, general framework, and then there is aspects of this that have to be transposed, which is this sort of social and environmental aspect of energy community. But then different countries, we see that different countries define energy communities in a different way. In some cases, they even combine these two concepts. We have countries where they say that energy communities can only be behind, let's say, medium voltage transformer. There is different ones that allow energy communities to be nationwide. So it depends. It depends on what you want to achieve with the energy community, indeed. Whereas when I talked about collective action is a bit broader concept, so that definitely doesn't need to be local.
Okay, and I have here another question, and it is that how can use of flexibility services such as aggregation help energy community last?
Well, energy communities, as I mentioned, they use different types of models, and what we see is that the more diverse, because we analyzed, what makes energy communities sort of last, or these community initiatives last, because if you only organize around one initiative, for example, I don't know, a specific energy efficiency service, then as soon as that service is over, the community might dismantle and not be used anymore for energy management. Whereas if the community uses multiple energy services, then that's something that helps it be more resilient to changes like what we see today with the energy prices increasing and the energy crisis. If you're doing more activities, then you're more, let's say, able to last longer. So in that sense, using different types of flexibility services, such as having, for example, aggregation of electric vehicles or having aggregation of heat pumps or boilers, at the same time would help an energy community be more diverse in what it can offer. And also having an energy community be bigger in that sense, then you have more consumers, they have different usages. For example, if you have consumers, households, but also some small and medium enterprises or let's say public institutions, then it makes it a bit more flexible to manage the energy within the community.
Okay, so thank you very much, Lucia, for your answers. I hope we will have more questions for the final or for the second round after the next presentation. Therefore, let me now to introduce, thank you, Lucia. Let me now to introduce our next speaker. I mean, he is Andre Madureira. He got his PhD in electrical engineering from the Faculty of Engineering, University of Porto in Portugal, 2010. He's currently group leader of the Sustainable Energy System Group at the Luxembourg Institute of Science and Technology. Previously, he was a senior researcher at the Center of Power and Energy Systems of INESC Tech. It was also an invited assistant professor at the Faculty of Engineering, University of Porto, and an assistant professor at the Luxofona University of Porto. He is the author of more than 50 papers published in international journals and conferences with peer reviewing, and co-author of 6 book chapters. His current research interests include integration of distributed generation in distribution networks, demand response, electrical vehicles, and smart grids in general. Today, Andre is going to give us a presentation about smart local energy systems dealing actually with energy is now going local. Okay, so please, Andre, you have a floor. Okay,
Thank you very much, Pedro. So I'll try to share my screen. You should be able to see it now, right?
Yes, it's okay.
Okay, perfect. So thank you very much, Pedro, for your kind introduction, and also thanks to Lucia for sharing the floor with me in this webinar on smart local energy systems. So I will take the opportunity now to go a little bit back on energy systems. What is the motivation that leads us to go local again? And I will start. Of course, this is something that's known to most of you. I would say what is actually driving this change. Um, Basically, this clean energy package set by the European Commission consists of a set of legislative acts that impact energy performance in buildings, but also renewable energy, energy efficiency, governance, and electricity market design. But what's more important about this is that it defined a set of goals that are very ambitious and need to be achieved by 2030. So this includes the 40% cut in GHG emissions, includes also an increase on the share of renewable energy within the EU's energy mix of around 32%, and also a target of around 33% of energy efficiency related to a baseline scenario. So we all know that this can be extremely challenging, and in particular, one of the requirements that the Commission has been putting forward is on the electricity market design. And why is this important? Because the new electricity market design rules have to make the energy market fit for the future, and this means that the consumer is ever more at the center of this clean energy transition. This is something that actually Lucia just mentioned, how important it is to have the engagement of citizens and citizen empowerment in order to be able to achieve these ambitious goals. One possible answer to this is, again, on energy communities. So this is a way, and Lucia explained it very well, is a way to organize this collective and citizen-driven energy actions. And this is expected to enable, to pave the way for a clean energy transition and moving citizens even more to the forefront. And let's not forget that the ultimate goal of these strategy by the EU is on its long-term strategy to achieve full carbon neutrality, which means net zero emissions by the year of 2050. And on purpose, I'm not talking specifically about the recent developments that we all know regarding the war in Ukraine, but it's likely that all of this will make the matters even more urgent. So after this, I will talk to you a little bit about what this represents for the country, Luxembourg, that is also dealing with this kind of problematics following the guidelines from Europe. So, of course, we have the goal, as the European Commission said, to have this reduction in GHG emissions. There are also some ambitious targets to grow substantially, especially PV installed capacity, more than 5 times. Also wind capacity around 3 times, and having 25% of renewable gross final consumption in our energy mix. This is extremely challenging for the case of Luxembourg, particularly because we know that around 85% of the electricity in the country is imported. And one other important aspect is that electric mobility is also expected to grow and to have around 50% of the fleet being fully electrical in 2030. So this means that there are huge challenges set for the country as well as for Europe. But in this specific case, it's even more challenging. And it's more challenging for one particular reason. So Luxembourg currently is a country that's highly dependent on imports, and particularly regarding electricity, we're talking about electricity imports that come mostly through 2 lines that connect to Germany. And these lines are already, in some periods of the year, already getting close to what is their capacity. So this will be a problem for sure in the future. And this high dependency means that the country is still not autonomous enough. And for this reason, there are a couple of challenges that need to overcome. The first, I would say, has to do with the lack of resiliency of the energy system. So especially given the situation today, the resiliency of the energy system is extremely important in order to be able to cope with unexpected situations and to ensure that that service can be provided at all times, and that the critical loads in particular are well taken care of, even in face of some unforeseen events. If we consider if we consider in addition that the security of supply situation is being more and more aggravated, and that energy prices are now raising at unprecedented levels, this means that we are set for a very challenging situation. And even now, so because we are increasingly vulnerable to external events, and the war in Ukraine is a very good example of this, with all these changes that come connected to this plan for Repower Europe. So it's highly likely that in the next few years we will see great changes being made on the way we operate and how we have our energy system in Europe safely maintained. And this goes to say that one possibility to mitigate some of these problems is to rely on ever more distributed generation, and also digitalization solution as an enabler, connecting to what we often call as smart grid technologies. On the other hand, the integration of new renewable energy sources, mainly based on PV generation and wind generation, that can occur both centralized large wind farms or large PV farms, but most importantly distributed, so near residences, for instance in communities, is something that will for sure play a key role. And this will unlock these local energy systems, and these energy communities could be seen as a way to further integrate these new actors into the picture. But Luxembourg has also a kind of solutions that are already there, and one is that we can take advantage of being this small country, where the proximity to the levels of decision is much easier than in bigger countries. Also, the possibility of having living labs that are able to test concepts and technologies is something that is easy to construct in such a small country. And of course, being an attractive location for providers and startups, given its framework around taxation, and making it an international hub in key technologies and innovation. So all of these combined are good opportunities that we should take advantage to address these challenges. And what does this mean? In particular, that it is expected that we'll be moving to ever more local, user-centric, distributed energy systems. So let's go a little bit back in history and seeing what are these local energy systems all about. So this is not a new concept. So back in the 2000s, some people in the US started talking about microgrids, and microgrids in the sense of having this cell that was fully controllable within the distribution system, that was able to coordinate and optimally manage a set of controllable loads, distributed generation, mainly based on renewable sources, but also storage devices in an autonomous way, and even disconnected from the main power grid. So these microgrids had the capacity to operate isolated from the main power system. This started in the US, but this also migrated to Europe, where there were two very big projects around this concept, and we're talking back to 2003, so almost 20 years ago, where this group of people decided to start investigating how we could have technical solutions to manage this kind of systems in an automatic way, not only through development of advanced functionalities and dedicated tools, but also developing and proving this concepts in reality in pilot situations. So these are just a few images of the control architectures that were proposed within the framework of these European projects. So if we take this into consideration, we can say that microgrids were already a thing, and Lucia mentioned it in her presentation. When we talk about isolated systems, so physical islands, so these were also already microgrids. We also have embedded microgrids, that is, microgrids that can be controlled either when they are connected to the main power network or when they are islanded from the main system. And finally, local energy communities, which is another piece to this puzzle, that in this case comprises consumers that cooperate in order to satisfy their energy needs by leveraging what is their local production and are not designed to operate in island mode. So all of this is aligned to what is the objective of getting the challenge of the energy transition closer to the user, closer to what are distributed renewable sources and these types of communities. So regarding these energy communities, they can be seen as a way to organize these collective energy actions around an open democratic participation in governments. And the idea is to have these benefits that could serve the members of the community, its members, and also the system. So some keywords related to this local energy systems. So first of all, it's related to decentralized energy resources. So leveraging what's the availability of the solar potential or the wind potential. So fostering PV generation and wind generation, for instance. Also on the shared used assets, and I will come to this point in a couple of minutes in the next slides. So Lucia also talked about this around the use of community storage solutions, which can be a very interesting means of sharing assets within a community to serve one community goal. Also, increased flexibility from all these resources, and if we include storage, even more so, in order to ensure what would be a cost-efficient and secure supply of energy to the consumers. This will also enable to have a more stable power grid, that it's not so dependent on the external power system, and will have the benefit to empower consumers in order for them to be a crucial step in this energy transition. So let's talk a little bit about now of some examples of what could be solutions around energy communities, going from an individual household until a community level. So I'm going to present here some results from a project that we have running in LIST on the optimization of buildings and communities, and talking about the bi-level optimization first at an individual building level. So considering one building with multiple appliances and resources that could be optimized using this home energy management system with a set of intelligent tools in order to optimize locally these resources, taking into account, for instance, objectives such as cost minimization, subject to end user preferences. So making sure that the preferences of the users are duly taken into account. This first stage, where the optimization of the building is done, would enable reaching an optimized power consumption profile for one building that could be then escalated for the community level. So here, for example, you can see some results of what would be the scheduling of HVAC systems over a 1-week period. And basically, this scheduling was done in order to minimize the costs of the energy, taking into account user preferences. And these user preferences were mostly related to the set temperature that was decided for each of the 3 types of buildings that we considered here in the study. So residential, office, and healthcare. So as you can see here, it was possible to schedule the HVAC systems in all of these buildings, taking into account that the temperatures would be in between the temperatures that were set by the users within these limits. Also, this goes to the next level where we move from an individual building level to a community building level. So now we are looking not only at individual households, for instance, but we are looking at a set of these buildings that are operated together and that share, that's exactly what I mentioned a couple of slides ago, a battery energy storage system that is shared within the community and that is used to serve the purposes of this community. The idea is that the management of such a system would be done through a set of local apps that are installed in the digital platform that is based on the cloud and that's able to monitor each of the community's members. So in this case, this community management system would be an upper level of control where we would take as inputs these optimized power consumption profiles for each of the buildings that compose the community, and then refining these profiles in a coordinated way in order, for instance, to achieve a community goal of maximizing the local energy community self-consumption or self-sufficiency. So in this case, we would define the scheduling for this shared storage device in order to achieve the goals of the community. And we can see some results here where we go from the individual buildings that basically, taking into account their user preferences, would enable to define what we call the flexibility envelope, so the possibility of demand to increase or decrease in each moment in time in order to respond to an external signal. And then going from this to the community level, where we would have this community shared storage system that would, in fact, be able to charge and discharge according to the objective function, which in this case was maximizing self-consumption. So, in order to schedule how the charging and discharging cycles would be, according also to the availability of the PV generation within the community. So we did more experiments on this, especially taking into account that in specific situations we could consider as a benchmark solution this centralized approach meaning solving the problem not in 2 stages as bi-level optimization as we presented, but in a single centralized problem. And we have seen that this purely centralized solution would have a huge cost when we would increase the number of buildings within the community. Whereas using the hierarchical solution, this bi-step, bi-level optimization, we could increase the size of we could increase the number of buildings and keep computational times relatively low. This was done for the case where we didn't consider shiftable appliances, so solving this optimization problem as a linear programming problem, or with shiftable appliances, which means we would be solving a mixed integer linear programming problem. So this was just to show that in all of these simulations that we have made, we are able to indeed follow the set points that would be defined for the storage system, and also for the individual households, and using this model predictive control approach that we developed in the project. And of course, the final level to this is the provision of grid support services. So in this case, we are talking not only of developing a solution that could serve the energy community and its members, but also to offer the remaining flexibility from the local energy community to the grid. And this could be seen in a set of services that could be provided, especially, for instance, concerning about balancing, congestion management, inertia, and this is something that could be exploited by the distribution system operator. So this is also to say that in LIST we'll have a set of living labs that we will be deploying in this year to have this community-oriented batteries that will constitute these living labs I've been talking about, and where we will test this kind of solutions in different locations in the country, talking about this the operation of this shared use battery energy storage systems, and fostering even more the deployment of energy communities in rural areas like this one in the north of Luxembourg, where we'll be talking with local stakeholders and municipalities to deploy this kind of solutions. So to finalize my presentation, some key takeaways. So and Europe is driving the energy transition and striving for carbon neutrality in 2050, but this doesn't come without significant challenges. These are reflected in the ambitious targets that have been set for Europe and Luxembourg, in particular in 2030, and this requires a change in paradigm. And especially given the most recent events in Europe, we will need to reduce energy dependency ever more and ensure a more reliable and resilient energy system, which means that local energy systems and energy communities in this matter can be seen as an effective way to cope with this increasing amount of renewables and other distributed energy resources in an efficient way. So just before I finish, this is the project from which we derived some of the results I presented here. So this Genesis project is a national funded project. The PI is Dr. Florin Capitanescu, and the team at LIST here contribute with a lot of these solutions that I presented here. And we also have some further reading with some papers that we wrote along these lines. So thank you very much, and this concludes my presentation. I'm happy to answer
position for a field technician. So far, I think I checked this morning, there was no candidate.
Okay, sorry, Andre. I don't know if you hear me now.
Yes, yes.
Okay, so thank you very much, Andre, for your presentation. It was quite clear. I mean, actually interesting to see all the work conducted in the different projects here list. I have here a couple of questions for you. Okay, now we have around 10 minutes. Okay, we are running well in terms of time. So I have two questions for you, and also we received two additional questions more for Lucia. So let me go first with you, Andre. There is a question regarding how can local energy systems contribute to improve the resiliency of the grid?
Okay, so in fact, these local energy systems can be seen as playing a key role in increasing the resiliency of the system for more than one reason. So first, as I mentioned at the beginning, even within the concept of microgrid, it's possible to design a system that can withstand external events, and in particular, if it's able to secure, based on the coordination between local production and storage systems, is able to secure its own supply in a self-sustained way, this will enable us to have a more resilient system. So in an extreme case, we can be talking about having islanded operation, and how in some specific conditions we can isolate a system safely and continue to operate part of the system in isolated mode, and then again resynchronizing to the main system when the power becomes available again. This is one part of the issue. The other part is also on how these local energy systems could contribute to restore the system. So, for instance, through black start mechanisms, where it's possible to do the restoration of the system in a kind of a bottom-up approach, especially relying on new control possibilities that are open through power electronic interfaces, where you have grid forming inverters and where you have the possibility to explore these solutions to start energizing the grid from the bottom up, and to sustainably start operating in small islands that can be later resynchronized to the main grid. So I would see that the two main aspects regarding resilience.
Okay, thank you. And I have here another question. It says, what is the role of shared use assets in local energy systems, mostly in energy communities?
Okay, so as Lucia said in her presentation, the idea of this energy communities is to go beyond what is in the traditional self-consumption or the traditional prosumer that is both a producer and consumer of energy, and that has its own means for sure. But in specific situations, and especially concerning energy communities, the use of assets such as presented in the slides, a common community-oriented battery energy storage system could be used to support the work of the community without relying on, let's say, more distributed solutions like having a battery installed at each household. So this has several advantages. For one, you have a bigger battery, which alone in costs, it's more interesting to have one larger battery than a few smaller batteries. It's also easier to operate and maintain, and it enables us to have a more flexible solution that could benefit the community as a whole and not individual customers in themselves.
Okay, thank you very much, Andre. And well, I have here some two more questions from Lucia. Okay, one of them is saying, what makes energy communities sustainable and or successful? This is for
yeah, this is we discussed this a bit at the beginning, and that's a question that we're trying also to answer with the projects, is sort of what are some of the indicators that we can use to say that a community is successful, that energy community is going the right way? Is it because it's growing in the numbers, or is it because it has more renewable energy installed, or it's offering more flexibility? These are some of the aspects that need to be defined that might not be the same for different energy communities. And this is something that I wanted to add maybe to what Andre was presenting. For example, for what we've seen doing a similar simulation with BUB for Belgium, taking into account Flemish, for example, regulation, is that we see that if you optimize using flexible assets per building, or you do this per community, you don't have much of, let's say, financial advantage doing it per community. And the main reason for this is the way that the tariffing is defined, but also what incentives do you have? If you have any sort of, if the DSO is offering any sort of remuneration for flexibility services, which is not the case right now, then maybe in the future this can become a bit more, let's say, profitable. Or if you go towards more capacity-based tariff, and then you say, okay, you're not going over your specific capacity, then for energy community, if you manage energy per energy community, then maybe this can become a bit more interesting. But for us, and it's really interesting to see how your project or your results would look like when you introduce different tariffs, and what would be some of the benefits for the members of the community. But indeed, this is one of the aspects when you talk about successful energy communities. You have to always keep in mind what is the regulation and what are the subsidies that are provided, because a lot of times regulation will define a specific subsidy around which all of the community initiatives will form, because there is a specific subsidy right now, and maybe in the long term that's not something that will function if the subsidy is gone. But indeed, this is a complete change in the way that the energy system is working. So you indeed at the beginning need to provide some subsidy to get people interested to join energy communities.
Okay, okay. And actually, the second question I have here from the audience is connected to this one, because someone is asking if you are aware about good examples, demo projects, where grid flexibility to the DSO is part of the business model of the energy community. I mean, could you share any example or any project that you know in this regard?
So indeed, within the 7 groups of business models that I presented before, that's in our publication, this sort of aspect of providing services as a community, providing services to somebody else, like to a DSO, is part of this, let's say, emerging business model, because indeed, as I mentioned earlier, there is few aspects that are still missing, and one of them is a DSO offering any sort of remuneration for that. The second one is also in a lot of countries, this is not yet defined, or let's say local flexibility markets are still not defined how they're going to function. And one of the main reasons is because DSOs don't have that, let's say, low grain flexibility of visibility of the grid to know at real time where they need specific, let's say, flexibility here or there, or where is it needed. So indeed, right now, most of the demo projects, as was presented by Andre, that I know, for example, the one that I mentioned in Belgium is in Oud-Heverlee, in a neighborhood where our company is, where we tried with this neighborhood where we're working with the neighborhood battery with the DSO together, of course, because that's part of the grid then in the end. And that's also the question of the regulation for the owned assets by the community. Maybe the community owns a battery, but still it needs to be maintained somehow with the DSO together, because that's part of their grid at that point. But there, for example, we're working with the DSO to see how much flexibility are we offering. But then in the end, as mentioned, it's not really a business model, because you don't have a specific remuneration for this flexibility. Right now, what we see mainly as a business model that's functioning is aggregation of let's say electric boilers, where you aggregate and you have more than 1 megawatt, and then you can offer it on the market. But for the local, it's only research projects that we see right now, and it's not a functioning long-term business model at this point.
Okay, so thank you, Lucia, for this answer and this information. Well, I think we were able to cover very well the schedule of for this webinar. We are already quick, perfectly on time. And well, I would like to thank you both for your very nice presentations, also for the discussion that we arise during this short time. And well, thank you all the audience for attending this seminar. Well, I hope to see you again in the next one. that will be leading or dealing with, let's say, digitalization on energy systems. Okay, so really, thank you very much.
Thank you for having us.
Okay,
Thank you,
well,
Pedro.
and see you again soon. Okay, bye bye.
Have a good day.
Yeah.
Bye.
Bye.
Bye bye.